One class of reactions that involve electron transfer are called oxidation and reduction reactions, or for short, redox reactions. These are common reactions that include things like antiseptics, iodine or hydrogen peroxide, or the rusting of iron metal. Some chemical batteries are based on redox reactions. And some things which are a little less apparent, like the combustion of methane gas to form carbon dioxide and water, is also an oxidation reduction reaction. Along that lines, one of the reactions in respiration is a low heat oxidation reduction reaction. So in this chapter, what we're going to try to do is look at the definitions that we can use for oxidation reduction, and given a reaction, identify what is oxidized and what is reduced. So there are two definitions of oxidation and reduction that will be used in different situations. The first definition is used when we can see an electron being transferred. Now, of course, we can't literally see the electron transfer, but how we can see it is by looking at the charges of the reactants in the products. So we're going to use charges of the ions by looking at So this first definition will pay special mind to charge. So here's the first definition, and notice the oxidation reduction, what we're looking at is the transfer of an electron. So before we go too much further, remember if you lose an electron, the charge becomes more positive. If you gain an electron, since electrons are negative, the charge is going to become more negative. So let's take a look at the definitions. So here's the first one for oxidation. And you can see here oxidation is the loss of an electron. So if we're losing an electron, what we're going to see is that the charge is going to increase. Now reduction, here's the definition, is the gain of an electron. And so when you gain electrons, the charges become more negative, so the charge is going to decrease. So it might be a point of confusion that reduction, how would reduction go with gaining? But when you think about the reduction, it's actually going to be over to here, a reduction in the charge. Now this definition has two little sayings that you can use to help remember it. I like the first one best, and I don't know why. Leo, like Leo the lion, says grr. And Leo means loss of electron is oxidation. And then grr, like Leo's growling, grr, G would be gain of the electron is reduction. Now, another one that you could use, and they both do the same thing, so it's not like you have to use both, is oil rig. And oil stands for oxidation is loss, and rig is reduction is gain. So oxidation is the loss of an electron, and the charge is going to become more positive. Reduction is the gain of an electron, and the charge is going to become more negative. Now, if you look down here, we'll also see some more definitions, and this will be used in both definitions, in both of the oxidation reduction definitions. But whatever substance is oxidized, that is also known as the reducing agent. So these two things are the same thing. The oxidized substance is also the reducing agent. I like to think about it as that the substance that's being oxidized also has a job, and its job is to reduce the other substance. So it's a reducing agent. Now the substance that is reduced, it also is called the oxidizing agent. So the substance that is reduced is the oxidizing agent. Now let's try a problem and see if we can apply some of these definitions. So here's an example of an equation that would be an oxidation-reduction reaction. Now usually, just to remind you, or maybe to tell you, if ions by themselves, they don't really exist by themselves, but they will exist dissolved in water. And what happens is, let's say I had iron with chlorine. If I put it into water, it does something called dissociates, and the chloride ions and the iron ions fall apart. And so when these equations, when they write this ion together, it will have an AQ behind it, because what they're telling you is that it's in water, and so the ions have dissociated, so they've fallen apart. Now I'm going to erase all those because we have other things we want to do, but I just wanted you to understand where that's coming from. So what we'll do here is we'll be looking at the iron. It's called a half reaction. What we're going to do is we're going to look at what the iron does on the reactant side and compare it to the product. So on the reactant side, iron is a 3+. And if we compare it to what it is on the product side, it's just iron metal. See here, it's a solid. And so iron metal would be neutral. It would have a 0 charge. So when I compare the charge, I have a positive charge, and my charge is decreasing to 0. It's getting more negative. So remember, to get more negative or decrease, we do that when we gain electrons. So the gaining of electrons is reduction. So iron, this iron 3 ion here, it is reduced. So now let's take a look at the aluminum. Now, by definition, the aluminum has to be oxidized, but because oxidation and reduction go together. It's an electron transfer. But let's take a look at its charge so we can think it through. So aluminum over here is just a metal, so it's neutral. I'll just write a 0 there to remind us. And when it comes over, it now has a 3+. So this is an ion that has been dissociated. It's in water. So the aluminum, my charge is going from 0 to 3+, so it's increasing. And charge increases when we lose electrons, right? It gets more positive. So we know the loss of electrons is LEO, oxidation. So just like we predicted, aluminum is oxidized. Now remember, I had a second definition, the oxidizing agent and the reducing agent. Well, if you're reduced, by the definition, your job would be to be the oxidizer. So you're an oxidizing agent. So iron 3+, the reactant, is the substance that's reduced and is the oxidizing agent. If you're oxidized, then your job would be, by the definition, the reducing agent. And so then the reactant aluminum is oxidized as well as being the reducing agent. Now notice I didn't label the products as being oxidized and reduced. It's the reactants that we're looking at. So now let's try the second definition, or the second equation. So I'm going to look at iodide. We're going to do a half reaction where we just look at one thing. So here I have iodide ion. And going on to this side, it's I2. Now the halogens are all the diatomic elements. I think we talked about that in a previous chapter. So it's going to be neutral. So I'm going from a 1- to a 0. So it's becoming more positive. It's getting from a negative number all the way to 0. So that's getting more positive. So to get more positive, it means we're losing electrons. So the loss of electron is oxidation. So iodine is oxidized. Now let's look at the bromine. So bromine is going from the elemental form on the reactant side, and look over to the product side, it goes to the Br negative. And I'm not worrying, these twos are used in balancing, and for what we're looking at the charges, we don't have to look at that. There would be instances in other classes you might have to, but we're just looking at the elements. So I'm going from a 0 to a 1 negative, so my charge is decreasing, and we know things decrease when they gain electrons because electrons are negative. So the gaining of the electrons is reduction. Now this is what we expect because we predicted that the iodide was oxidized, so we would know the bromine had to be reduced. Now again, applying the definitions, if you're oxidized, you would be a reducing agent. They go together. The iodide ion is that. And if you're reduced, you would be the oxidizing agent. And so they go together. So we can apply the first definition when we see that there's charges, because the charges help us identify if the electron is being lost or gained. Well, there are some reactions that don't contain ions, so that's where we get definition 2. So when we cannot see any ions, we use definition 2, and if you see here, now our definitions are going to be based on oxygens and hydrogens. So let's look at the two definitions. So the first one is oxidation. Now oxidation says it's the gain of oxygen and or, which means both things could happen, or only one, and or the loss of hydrogen. So notice that if we're gaining the oxygen, we're losing the hydrogen. Then reduction is the opposite, the loss of oxygen and or the gain of hydrogen. So it's loss and gain again. Now I don't have any cute ways to remember this, and I kind of wish I did, but instead what I do is when I see the word oxidation, I think of oxygen. And so when I see oxidation, I associate that with gaining oxygen. Now honestly, that's the only thing I would have to remember. Because if I remember that it's gaining oxygen, I remember that the other part of the definition is the opposite. So if I'm gaining oxygen, I could be losing hydrogen. Then for the reduction, I think of oxygen as well, but I'm reducing it. So I think about the loss of oxygen. And remember, the hydrogen would be the opposite. So if I'm losing hydrogen, reducing oxygen, losing oxygen, then I would be gaining hydrogen. So let's see, think about these definitions, and let's look at some examples. And the examples here on the bottom I have rewritten so I have more room. So here are the examples, and these can be a little bit harder to put together what we want to look at, but I usually find my carbon and I kind of follow it through from the reactant to the product. Now I'm not really looking at the carbons, but I'm looking at the hydrogens and the oxygens that are with it. So in this one I have 4 hydrogens and I have 6. So I think to myself, I have gained hydrogen. Now remember, in the definition, it doesn't have to have oxygen and hydrogen, but this one has both. And so now I look at the oxygens, and this one I have 2, and this one I only have 1. So I have lost oxygen. So the definition is if I gain hydrogen and lose oxygen, the loss of oxygen is reduction. So this guy is reduced. Now, that means that hydrogen here is going going to be oxidized. But let's look at it just to follow the definition through. So now I take my hydrogen and I follow it over to the other product, and I see the hydrogens are the same, but I have gained an oxygen. So gaining of oxygen, that, remember it's and or, that means this is oxidized. Now, if I'm thinking about the reducing agents and oxidizing, so the first one is reduced, so it's the oxidizing agent. And so that would be this substance here is reduced and being the oxidizing agent. And then oxidized, this is the hydrogen is the reducing agent. Now I will tell you one thing that sometimes is a real big shortcut for me, and that is that hydrogen is always a reducing agent. So understand how these, in these definitions, how everything's kind of the opposite. If I recognize hydrogen as a reducing agent, then I would also know that it's oxidized. And then if I know if hydrogen's oxidized, whatever it's with must be reduced. So this little bit of information right here sometimes can let you reason what's oxidized and reduced. Now let's look at the second one. And so here's my carbon, and remember I kind of follow it through to see what happens. There's 4 hydrogens here and there's none over here, so it looks like I've lost my hydrogens. And there's no oxygens here and there's 2 here, and I've gained oxygen. So the gaining of oxygen means that this first, the methane, the CH4, is oxidized. And so now, just to confirm, I know the oxygen would have to be reduced, but I will confirm it. So looking over here, this one has gained hydrogen, and it's gone from 2 oxygens down to 1, so it's lost oxygen. So the losing of oxygen, the oxygen is reduced. So when I go back, if this is oxidized, it is the reducing agent. So methane in this combustion reaction is oxidized, and it's a reducing agent. And the oxygen is reduced, and it's an oxidizing agent. Now, to tell you another little trick I use, oxygen, O2, is always an oxidizing agent. It's going to add oxygen. That's what oxygen job is, to add oxygen to things. So it's an oxidizing agent. So again, I can reason, if oxygen's an oxidizing agent, then I know it has to be reduced. If oxygen is reduced, whatever it's with has to be oxidized. So sometimes just knowing that oxygen is an oxidizing agent, it allows you to solve these problems relatively quickly. So the goal of this chapter for us is to take a reaction and be able to apply either definition 1 or definition 2 to identify the substance, the reactant that is oxidized, and the reactant that is reduced, as well as be able to apply the definitions of oxidizing agent and reducing agent.